Now that we've got the notion of limit, we can use that to talk about what Calc 1 is really all about, and that's the notion of the derivative. Here's the idea. We want to be able to look at a function, y equals f of x, and to be able to say at any point here, what's the slope of a tangent line? That is, we want to, what's the slope of the function at that point? But the slope of the function we think of as the slope of a line that's going in the same direction right at that point. And so I'm going to look at the derivative in a couple of different ways. One is just at a point. So let's pick the point x equals a here. Okay. So it's hard to say what the slope of a line is just by knowing one point. I can find, take x equals a and plug it into the function and find the y value here. So that's at f of a. So I know that the coordinates of this point right there are a comma f of a. But that doesn't tell me the slope of the line because I need another point. So what I do is I'll pick some other point here. Let's just say x. And that gives me a point on the curve as well here. Coordinates of there would be x comma f of x. And if I look at the line that goes through those 2 points, well, that's not really the line I'm interested in, right? But I'm going to use that, right? So that red line is what I call a secant line. It hits in 2 points. And I can calculate the slope of the secant line here. The slope of the secant line is the rise over the run, the change in the y divided by the change in the x. Well, the change in the y is just the difference in the y coordinates. It's f of x minus f of a. Right? Likewise, the run is the change in the x coordinates. Well, the x coordinates are just x and a, so x minus a. So the rise is f of x minus f of a. The run is x minus a. And that's the slope of that secant line. Now, let me zoom in on this here and say, this isn't really right. What I want to do is I want to say, well, what if I took a point closer to a? So rather than x being clear out here, let's take x to be here and use this point. And then I look at that line. Oops, that didn't go through my 2 points there. So I look at that line and say, well, that's closer to this tangent line. And they say, well, wait a minute, why don't if I take x even closer? So I'll take x on the curve down here, and then I'll use those 2 points to determine my secant line. And the idea is you're taking x's closer and closer to a. This was a, remember, and looking at the slope of the secant line. And we're claiming then that the limit of the slope of that secant will become the slope of the tangent line. Okay. And if the limit exists, that's what happens. So we say then that the slope of the tangent line is the limit as x goes to a of f of x minus f of a all over x minus a. So this is the slope at that particular point. That's not going to tell me anything about what's over here or over there, but just at x equals a, here's what's going on. And this, we make a definition here. It's called the derivative of f of x at x equals a. The notation, there's several notations that we'll use, but for mainly we'll use this thing as the f prime of a. That's kind of like a single quote, just a hash mark there. F prime of a is equal to exactly this, the limit as x goes to a of f of x minus f of a over x minus a. We don't have a way of precisely doing the, well, to do the slope of the tangent line, the process we have to use is say approximate it, and then get a little better approximation, get a little better approximation, a little better, and as you get this point closer and closer down there, those secant lines become closer and closer to a tangent, and in the limit we get the slope of the tangent line. Okay, let's do an example. And so how about, let's take the function f of x equals, let's just say x squared. Okay. And I want to let a equals 1. So I'm going to look at y equals x squared. So it goes through 0, 0, 1, 1, 2, 4. You got your standard parabola here. I want to know the slope of the tangent line at that point. Well, just by zooming in and looking, I can see that, for instance, this line right here would have slope 1, and this is probably steeper than that. So I'm expecting an answer bigger than 1 here, but what exactly it is, I don't think it's immediately obvious. So here's what we do, right? I'd say that f prime of 1 is the limit as x goes to 1 of f of x minus f of 1 over x minus 1, right? That's just the definition that we have right here. Now applying this function to that thing, this is the limit as x goes to 1. Well, f of x is x squared. F of 1 is 1 squared. And that's divided by x minus 1. If I try just plugging in the x equals 1 in, I've got 1 squared minus 1, that's a 0 on the top, a 1 minus 1, 0 on the bottom. 0 divided by 0 always means that I probably have more work to do. There might be a limit, and so I'm going to try a factor and cancel method here. So I've got the limit as x goes to 1. The top factors into an x plus 1 times x minus 1. And of course the bottom is x minus 1, and it's like, all right, there we go. There's my factor that's causing the 0 on the bottom. There's the factor that's causing the 0 on the top. Now that I've canceled those factors out, I can just plug the 1 in. So now I've got 1 plus 1, and the answer here is 2. The claim is that the slope right here is 2. Okay. If I wanted to try this at another spot, let's try it over here at let's say -3. Okay. Well, f prime of -3 should be f of no. It should be the limit as x goes to -3 of f of x minus f of -3 all over x minus -3, right? So I'm doing the same thing I did here with the 1. It's just that I'm using -3 to find what the slope is over here now, right? Actually, that looks like it probably should be a negative slope. We'll see if that's the way it turns out. So this is equal to, all right, I'm going to apply my function. What was f of x? F of x was x squared. So this is the limit as x goes to -3 of x squared minus -3 squared over x, and the negative becomes +3. Okay. So this looks like the limit as x goes to -3 of x squared minus 9 over x plus 3. Plugging in the -3, oh, it's 9 minus 9 on the top, that's a 0 on the top. It's -3 plus 3, that's a 0 on the bottom. So looks like I need to do a factor and cancel here. Limit as x goes to -3. X plus 3. This is the x plus 3 I know is the thing that's causing the problem. So let me find that factor of x plus 3 on the top. It turns out I need an x minus 3 to go with it. And there's the 0 over 0 finally canceling out. Plug in my -3. Minus 3 minus 3 is -6. So my claim is that on this graph of y equals x squared, right, 0, 0, 1, 1, 2, this thing right here, and when you're back at -3, wherever that is, that the slope, is -6. Okay. So this is the way that we calculate the slope of a function at a particular point. We'll do a bunch more examples in other videos. But this is just one point at a time. I'm figuring out at x equals a. What I want to move on to in the next video is saying, let's not just do it at one point. Let's find something that'll tell me the slope at any point. Okay. So here we go.